Alright, this will be the first video in a series of videos regarding complex numbers. So if we just dive straight into it, I think the playlist will be about 10 to 15 videos, and then the length will vary a little. But in general, I'll try to make the videos around 7 to 8 minutes, and we will see why complex numbers are so useful and powerful in mathematics. First of all, let's just motivate why do we need the complex numbers. So what we want to do is solve equations like x squared equals something negative. So for example, equals -1. Now this is not possible usually, because if we have -3 squared, then we would have 9. But if we just had a positive number, 3 squared, we would also get 9. So it's not really possible for us to square a number and then still get a negative on the other side of the equal sign. So what we would like to do is we would like to introduce I, and I we define as the square root of -1. So if we take I squared, then we get -1, because to square it just cancels the square root. Alright, if we have a general complex number, we could call it C, then it's equal to A plus I times B. Now, the reason why we use C instead of maybe X or Y is simply because it's easier that way to know that we're talking about complex numbers. Usually we use X and Y for our functions, but in general we could just might as well call it X and call it like C plus I times D. So it doesn't really matter, but the general notation is that you use C for complex numbers. Alright, if we have our complex number like this, then we can see that we have one part that is multiplied by I, and we have one part that isn't multiplied by I. And we call this the real part. So the real part of C, that would be the part that is not multiplied by I, so that would be the A, whereas the imaginary part of C would be the part that you multiply by I, so it would just be B. And notice here that we don't include the I. So the imaginary part is simply what you multiply I with. So in this case, it would be B. Now we can also see now that if, for example, B equals 0, then C would just equal A. And A is just a real number, and in that way we could have that C is actually a real number. So inside the complex numbers, so inside this number, we already have all the normal numbers, like all the real numbers we're used to dealing with. But at the same time, if we instead had that A was equal to 0, then C would be equal to IB, and we would have something purely imaginary. So if the real part here equals 0, then you have an imaginary number, and if the imaginary part equals 0, then you have a pure real number. But we are mostly interested in this combination, and that is the complex numbers, of course. Now, why do we need, let's just take a look ahead, why do we need complex numbers? It's very useful, and you use it in a lot of fields of study. For example, you use it in electromagnetism, you use it in quantum mechanics, and also signal processing, and a lot more fields. So it's very useful to know what complex numbers are. Now, the main tool from the complex numbers that we would like to use is the complex exponential function. So it's e to the power of c, and if we just write out what c was, then we have e to the power of a plus ib. So this is where we would like to end when we are done with this series of videos, because then we can see it's a very powerful tool. It helps us deal with differential equations in a whole new way, or at least it makes them a lot easier to deal with. And in addition, we'll also see later on how we can redefine cosine of x and sine of x using the complex exponential function. So stay tuned for the next videos, and we will start by seeing how we add and subtract complex numbers.